All right, everybody. So we are in the next lesson using volume formulas. I'm on slide 6, which is on cylinders. And of course, there is a volume formula for cylinders, which the ACT is not going to give you, so you're probably going to have to memorize it. All right, so let's see here. We got here volume of enclosed cylinders. So I'm going to click on my GeoGebra. Okay, so I've got a cylinder here. It looks like the radius is 12 and the height's 14. They go ahead and give me the formula, which is pi r squared h. Alright, so let's see what I gotta do with this. Alright, manipulate the radius and height of the cylinder, setting different values for each. Record the radius, height, and exact volume of the cylinder in terms of pi. In terms of pi means pi stays in your answer. ACT likes doing this because they don't like decimals, so they'll do all the math except for the 3.14 in the calculator, and then whatever number they get, they'll stick the pi symbol right behind it. All right, so looks like the first one's done for us. Okay, so they got a radius of 10 and a height of 14. Well, I'm just going to go with what I've got, 12 and 14. So there's radius of 12, height of 14. All right, so here they actually use the 3.14 to get the calculation, so we don't want to do that. We want to do the r squared h, and then stick a pi symbol right behind it. So I'm going to come over here to my calculator. R squared times h, so it's going to be 12 squared times height is 14, so it's going to be 2016 with a pi symbol. Now pi is in your equation editor, so you're just going to hit pi and hit OK. Okay. All right, let's do another one. I'm going to change this to about a 10. All right, so radius 10, height 14. So radius 10, height 14. So again, it's r squared h, so this would be 10 squared times the height 14. That's going to be 1400 pi. Going to go into my equation editor to get my pi symbol. All right, one more. How about this time I change the height? Let's make it a 12. So radius 10, height 12. Radius 10, height 12. Again, 10 squared times 12, be 1,200, and a pi symbol. So don't forget, again, the ACT likes doing this because they don't do decimals. So they like to keep it as easy as possible. So there's your formula, pi r squared h. ACT more than likely is not going to give this to you, so you're going to have that memorized. All right, question 2. Suppose that you want to design a cylinder with the same volume as the given cylinder, but you want to use a different radius and height. In general terms, how can you change R and H to produce the same volume for both cylinders? Honestly, you probably have to just switch them up. Let's see, if you increase the radius, that means you'd have to decrease the height. If you decrease the radius, then you have to increase the height. So you'd have to switch their measures. If you increase the radius, then decrease the height, and also vice versa. If you decrease the radius, then increase the height. So that should have been a comma, that should have been then. Increasing. Okay, so yeah, just switch them up. All right, question 3. Using the online tool, find 2 different combinations of radius and height that produce 2 cylinders with nearly the same volume. Record the dimensions and volumes of the 2 cylinders below. Okay, so let's see. Let's make this a radius of 9. And let's make this a height of 8. Okay, so it's about 2035, 75. So 9 and 8. 9 and 8. Alright, if I switch them, make this an 8 and 9. I want they'd be smaller than that, won't it? Alright, so let's write this one down. So volume is pi r squared. So I had what, a 9 and an 8. So 9 squared times 8. Alright, so let's see what that is. That's going to be roughly, that's at 81, so 9 squared times 8. Okay, 648 pi. 648 pi. Alright, so let's see. To get a 648. 648. I'm trying to think my multiplication tables. 6 squared is 36. Let me try that. 6 squared 36. Oh, come on. Oh, come on. Get on 6. Here. Alright, so let's see how high I'd have to go up. Oh, I'm almost there. Oh, hang on, back up. Was it 18? It's pretty darn close. Yeah, there it is. 2035.75. So 6 and 18. So pi 6 squared and 18. And that's going to be 648, won't it? 6 squared times 18. Yeah, look at that. 648 pi. 648. Whoop. 648. My goodness, I can't type today. 648 pi. 648 pi. Is that what they used? Look at that. They used the same one. All right. Question 4. When you look at the two cylinders with these values of radius and height, we need to notice about the proportions of the cylinders. Okay, so basically, you'd have to switch them up like we did before. One has to be wide and short. One has to be wide and short. The other has to be not wide, but like thinner, skinnier, tall and thin. Tall and thin. So wide and short, tall and thin. They had to be opposites of each other. Short and wide, tall and thin. Ha! All right, so there you go. Question 5. Which has the greater effect on the volume? Change the radius by a given amount or changing the height by a given amount? Hands down the radius, because that's the number that's squared. Radius is the number which is squared. So it has more effect. Change the radius, squared. Okay. They and I are thinking a lot alike. Question 6. Using the algebra skills, how can you rearrange the volume for the cylinder of V equals pi r squared h2? Find an expression for height when you're given the r and v. Remember to perform the same operation on both sides. Okay, so they're basically asking us to solve the equation for h. Yes, okay. Make sure I understand what I was reading there. V equals pi r squared h. All right, so we're trying to get h by itself. Well, right now this pi and the r squared is all being multiplied. So the opposite is to divide by pi r squared. All right, so we're going to have a fraction here. It's going to be v on top divided by pi r squared. I'm going to use my equation editor. So volume over pi r squared. I'm going to do r squared. Oops. Yeah, there we go. and that's going to equal h. Okay. So let's see, is that all I wanted? Yep. Okay. Oh, self-evaluation. That's not too long a lesson. So it looks like we're really just kind of manipulating things, trying to decide how things kind of fit together. Definitely need to know this volume formula for a cylinder, pi r squared h. I've seen it on the ACT, so make sure you know that formula. All right.